In this episode, we discuss the real-world applications of OPC UA PubSub. My guest on this episode is Praveen Kumar Singh. Praveen is the Chief OPC Solutions Architect at Utthunga, where he leads Utthunga's OPC-based product engineering and OPC product portfolio. He has more than 21 years of experience in implementing OPC solutions for the oil and gas industry and other industry verticals. And he also holds 3 patents in OPC technology. A quick thank you to our sponsors. This episode is made possible by our friends at HiveMQ, who are providers of an enterprise-grade edge and cloud-based MQTT broker. So please do check them out to help support this podcast. Welcome to the 4th Generation podcast here on Industry4.tv, which is a series of weekly interviews designed to help you learn industrial IoT from some of the world's leading practitioners. So if you're new here, please make sure to subscribe and click on the notification bell so that you never miss any of the interviews. If you find this conversation interesting, please review it with 5 stars on Apple Podcasts, follow on Spotify, and you can also connect with me on LinkedIn at Kudzai Manditereza. So Praveen, I would like to welcome you. Thank you so much for coming onto the show today.
Thank you. Thank you very much.
Okay, so today I want to talk to you about OPC UA PubSub and its application in real-world industrial applications. So to set the stage here, can you begin by giving us an introduction into what OPC UA PubSub is?
Sure. Before I begin my answer, thanks for calling me on this podcast, Kudzai. I actually see your podcast regularly, and it's a great help. I mean, you are actually giving a knowledge very easily and a very simple language. Okay. So before I explain the PubSub, let's understand the need of the PubSub, and for that, let's go back a bit in time. Okay. See, what happened is in the late 90s. Okay. OPC Foundation came together, or the OPC Foundation was established by the automation companies because they had a need to exchange the data between automation products. Okay, which was not a possibility till that time. It was very hard. Okay, and that time they came up with the first set of OPC specification, which was built on Windows on COM/DCOM, and actually that specification became a very big hit. It was massively adopted in the industry. Okay, and because it was massively adopted in the industry, now there are more use cases. There are different people coming from different verticals and saying, "Hey, I want to use this protocol. It looks great," and that's where their limitation came in, because then they realized that this product, the specification is stuck to Windows, is working on COM/DCOM. Okay, and then OPC Foundation set out to build a next set of specification, which is called OPC UA. Okay. By the way, do you know what is OPC means actually? What OPC mean originally? OPC originally meant OLE for process control. The original definition was OLE for process control, which meant, now OLE means object linking and embedding in Microsoft Word, where you could move object from Excel to Word. Okay, and they wanted something similar to bring to process control industry, and that's why it's called OPC. Then they made it to open process connectivity, and now it's just OPC. They have removed all the definitions. Just OPC UA. So coming back to OPC UA, so this time they wanted to take care of all those problems that we talked about. Okay, where they are tied to Windows, and they had a duplicate specification or duplicate functionality, different specification for historical alarm event data access. So when OPC UA was started, it was started in 2003-04 time. Okay, and took a lot of time. They took like 3-4 years to build the first version. It came in I think 7-8, but by the time it became stable and it got market adoption was 11-12 time. In 2011-12, the industry really started adopting OPC UA, but they took so much time. But when it came out, it was worth, because it was a disruptive innovation. OPC UA moved from the simple protocol to being a framework, where communication protocol became one layer of it. Okay, on top of that, you have information model where you can define your own objects, a type system basically. And they also gave a flexibility to the other vendors to define their own information model on that information model, because it was extensible. Okay, so original version itself has 2 protocol, which was like TCP/IP, using OPC UA binary for planned communication, real-time communication, and you had HTTP or SOAP for web services. So an OPC UA server could have worked as a web service also. Now that HTTP and SOAP is deprecated, but it was there. Now, because they gave the information model, which is extensible, other bodies became interested. And that's where companion specifications started becoming a reality. Okay, now different bodies wanted to use OPC. And now you have, you started having this OPC UA for BACnet, you have for PADIM, for ISA 95, and the companion specifications started coming in. And OPC UA started moving on, it started getting market adoption. Now, and as this is happening in 2014-15 time, cloud came in big time. Cloud became a reality where Azure and AWS came in the marketplace. And now people started moving towards Azure. Now in automation industry want to move to Azure. But here, now Azure or cloud work on the messaging technologies, and OPC UA was TCP/IP and HTTPS, right? But industry said, okay, we want to now move our OT data because now we are going to a cloud for all the analytical purpose, to get the patterns out of the data. How do I move my OT data to corporate layer or to the cloud layer? And again, OPC UA was the answer because the framework was designed so flexibly, they actually just added a new protocol. Then they came up with OPC UA PubSub, where they just added a new protocol layer, which is messaging protocol, which can work on MQTT or EMQP or UDP, and they designed a corresponding information model, and just the framework became extensible. There was a new layer that added to the OPC UA framework, and that became the answer. Because it was already designed, the information model which was there for TCP/IP was available on the PubSub. It became the de facto protocol to move all the OT data from automation industry to the cloud. And that's why OPC UA PubSub became a hit, and it got an adoption much faster than OPC UA TCP/IP because it was catering to a different territory which was not there. Because for OPC UA TCP/IP and for other plant communication, classic window, OPC classic is still working. It is still there, right? So adoption there is slow. But here, there's nobody else to do the same job with so much of information. And that's why PubSub got adoption so fast. Okay, so that's how OPC PubSub came in the picture. Okay. Does that answer your question?
Yeah, sure, absolutely. It's always good to understand the background into how it came about, so that at least it will provide some context as we discuss along and as we explore this technology. So maybe now to give our audience a sense of where or how they could implement OPC UA PubSub, can you talk to us about the real-world applications of OPC UA PubSub?
Sure. So, see, what happened is when OPC UA came, right? When OPC UA came in, as I said, it was disruptive innovation, right? I talked about information model in the last answer. Now, let me add some more characteristics, right? OPC UA came with their own stack. They had their own communication stack. Okay, now you had a C stack or Java stack or .NET stack. What it essentially means is OPC UA became cross-platform. The native framework I'm talking about, the Bridge framework, became cross-platform. That means it can work on any platform. And because it can work on any platform, it can go to different layers of automation stack, which is used in plant, L1, L2 layer, where you have failed devices or HMI. Now, OPC UA, which was just on level 2 or 3, now can come to 1, okay, below also. And you get the data on the PLC level also. So OPC UA started going through the different layers, but it was still hierarchical. With the TCP/IP, a level 2 can talk to level 3. Okay. But with the cloud coming in and all that, now they wanted to have a data going all the way from level 1 to the cloud. Okay, now you have a use case where you have a device. Okay, we have a PLC which is moving the data in TCP/IP way to the next layer for the real-time communication. At the same time, you want that same data to go to cloud for analytical purposes. That you could do with the help of PubSub. And when PubSub came to these devices, this PLC control, edge computing, that is a very famous word, right? You hear that edge computing so many times. What exactly is edge computing, right? You are making an edge device to able to move a data to the cloud layer or the corporate layer. And OPC UA PubSub is the platform on which this became a possibility. So anywhere when you want to move a data from the lower level devices direct to a cloud, to a corporate cloud, we use OPC UA PubSub.
Now, let's talk about embedded OPC UA PubSub. Right. So first of all, what is embedded OPC UA PubSub, and under what scenarios would it be required in industry?
Okay, so what I just explained, right, on the PubSub, let me just extend that answer, that way the context is maintained, right? So I just mentioned that, OPC UA, PubSub can work on PLCs and controllers, right? Now, before PubSub was there, what used to happen? Before PubSub was there, what used to happen is OPC UA PubSub, a PLC controller was sending a data in a field protocols to the next layer. Okay, so at the lower level, where you have different RTUs, PLCs, other devices, there were a number of protocols. You have a Modbus, you have Allen Bradley, you have Profibus. Okay, there was plethora of protocols there, and they all were moving data to the next layer. Now the problem was when you speak so many protocols, which is just like a language. The way you have your own language, I have my own native languages. Whenever this language convergence is happening, there's a data loss, there's a corruption that is happening because it is never one-to-one mapping, right? That's one part of a story. Now, if you think about real plant, if you go, I have been to a real plant and I know the maintenance becomes a headache. The plant I was, they had actually a team. There were a team of 2-3 people just to manage those protocols. And there were 2 people for one protocol, not in all the protocols. Because not everybody can understand Modbus or Profibus or Allen Bradley, right? So there were like 20 people just there to debug those protocols. And it was really headache. Okay. Now, the same vendors that we're discussing, who had this field protocols, what is happening is all the OEMs now are moving towards OPC UA embedded. What they are doing is they are putting OPC UA in those devices directly. And that's where another aspect of OPC UA comes in. See, when OPC UA was developed, they gave different profiles of OPC UA. What means is you can define a UA server in different capacities. You can have a nano profile server, you can have a micro profile server, which is smaller servers running on the smaller devices, or you can have full-fledged server running on enterprise machines. And when you add a PubSub layer on that, okay, now what is happening is the same device practically became the edge computers or the edge devices that we discussed last time. So this is a practical implementation of edge device, because when it's a small device, you cannot have all the OPC functionality running there, right? So just implement what you want, okay, and start pushing the data upwards. So actually embedded OPC UA PubSub with TCP/IP, okay, actually is a practical example and a practical use case. Does that answer your question?
Yeah, absolutely. Now, in an OPC UA PubSub network, is there a way of configuring the participants for them to be able to exchange information? And if so, how does that configuration mechanism work?
Okay, so see, what happens is you require a couple of components, right, in the OPC UA PubSub world, right? So here I'll take a reference of your own podcast, the way you have explained in the last podcast, right? We have publisher, we have subscriber, we have a middleware, which can be a broker or brokerless, right? Now, to get a PubSub started on the network, the first thing you need a publisher. A publisher is nothing but a source of information, okay? So if you ask me, if I have to suggest to the end customer, you should always have a publisher maybe built on OPC UA server. Because if OPC UA server is a publisher, okay, you have almost all the functionality that is needed in future. Okay, you can have another protocol inside of TCP/IP, which is having a publisher, and you get all the publishers in the network. Now, next thing is the broker. You can have broker or the brokerless environment. So let's leave this for a time and go to the subscriber. Subscriber is the consumer of the information. Again, in a TCP world or OPC UA world, client was the consumer of the information. So a client can be a subscriber, but not necessarily. There are use cases where publisher need not be UA server, or client need not be a subscriber. But I'm just giving an ideal case. So once you have publisher and subscriber established in the network, now what's the next thing? Next thing is you have to have a common understanding of what information you want to exchange, right? And that common understanding of information that you want to exchange can come via information model, okay, or via a discovery process that we will discuss in some time. But the discovery, you can get the information that you want to share across. So the subscriber should know what data is coming, in what semantics is coming, what context it is coming, okay, and there should be a mechanism to exchange this data, okay. If you are OPC UA server and client, there are multiple ways to get the data. You can simply use the PubSub information model, configuration model, to get this data, or you can use the dataset metadata to get this data. I mean, again, I will refer your last podcast where I explained this very nicely, so I won't go in detail. You can get a dataset metadata to the subscriber so that he knows how to interpret the information, and then it's just a package getting passed. Now, coming to the last piece of the setup is the brokers or middleware. Okay, in case of a broker mechanism, you can use either one of the brokers like MQTT or AMQP, or in case of brokerless mechanism, you can just have a UDP multicast network where UDP multicast will take care of all the message routing that is happening. Okay, so that's how you go about configuring all these components.
Oh, awesome. One of the most important things to be able to achieve when setting up a network of industrial IoT systems is to be able to discover what components are part of your network and other system-related information, of course.
Yes.
So how does the discovery process work in OPC UA PubSub?
Yeah, okay, so I just want to again go back, let's go back and see what discovery means, right? So discovery literally means, at least in a world of OPC UA or OPC, right? Discovery means find out the source of information, right? We are trying to find the source of information so that we can connect to it, right?
Yeah.
Now, in case of OPC Classic, earlier days, there was a component called OPC Enum to get all the servers, okay? In case of OPC UA TCP IP, we have an LDS service or GDS service to find all the OPC UA servers. Now, at that time, why we were trying to find the servers? Because it was point-to-point communication or peer-to-peer communication, where client is directly connected to the end server and is getting a data. So if he just finds the end server, the rest is easy, right? And that's called discovery in the OPC UA TCP IP world. But in case of PubSub, the publisher and subscribers are not connected. It's a decoupled architecture, right? Subscriber did not know the publisher. What he has to find is from where the information is coming. So if he can just connect to the broker, in case of a broker mechanism, suppose you have a broker as a middle layer, if he can find the broker and he can use the broker to find all the information, okay, that is enough for him. Okay, if you can find what are the topics, what are the publishers, okay, what are the metadata that is coming out of it, that's good enough. And you have so well explained that in your last podcast, right? The MQTT wildcard. Yeah. So I'll not go in detail with that. So the broker part, that is how you do it. Now, in case of OPC UDP or OPC UA PubSub UDP, where the broker is not involved, there the part 14 of OPC UA specification defines a very nice mechanism where you have a discovery addresses or a discovery probe messages, which are sent to discovery addresses. Okay, so typically what happens in case of PubSub, publisher is the one who sends them data and subscriber is the one who's consuming data. But in case of discovery, it is the subscriber who starts the message. There has to be a discovery probe message, which can be sent across to a specified address given in the specification, is already defined. And publisher can start responding to those messages and can give different kind of data. Okay, now this is in case when the whole network supports this kind of a back channel communication where subscriber to publisher communication is available. But suppose the network does not allow for whatever reason, then it is expected that publishers should keep publishing this discovery publish address, okay, or discovery announcement messages periodically on the network, okay, about what endpoints it has, about what configuration it has, what confidence changes that has happened, which can cyclically put that data. So there could be different mechanism. If it is the channel back channel is allowed, let the publisher send the discovery probe message, and in the response, he will get the discovery announcement messages. Does that answer your question?
Yep, absolutely. Okay, so now to move to another topic, that one of information modeling. Mm-hmm. So, I mean, if you ask me what the superpower of OPC UA is, I would certainly say it's the information modeling capabilities,
Yes.
So can you tell us about information modeling in the context of OPC UA PubSub?
Yeah, so as you said, OPC information modeling was the key. It was information modeling because of OPC UA became such a big hit on, it got adapted, companion specification came out, because now different bodies could represent their object, right? And because of that, the reason of that adoption is the way PubSub is defined is that information modeling agnostic of the communication protocol that is used on the communication layer. Okay, so the information model which is being built in the OPC UA is common to both of them. You can have a same information model which is used for TCP/IP and which is used for PubSub also. Now, what you can do is, in case of, see, as I said, in ideal scenario, as I said, I see in the future a server will have TCP/IP as well as the PubSub going together in a UA server. Okay, so if you are a UA client is the best way to access the full information model. You get almost everything. Okay, now I'm talking about the data information model. Okay, of the objects which are being exposed by the underlying net, hierarchy. What is their assets? What is their field devices? Which are, but now there's a second part of the story, which the information model for the PubSub itself, which is called as PubSub configuration information model, right? When you have built a PubSub capability, what are the PubSub connection you have? What kind of writer you have? What metadata you have? Okay, if you want to access that completely, you should be a UA client. If you have a UA client, you can access it very easily and you can get almost all the information. But suppose you are just a subscriber and publisher, you are not really a fully qualified UA server, then data set metadata that we discussed some time back comes in. Okay, the same information model. Information model basically is what? It is just adding a context to a data, a semantic to the data, right? And a data set metadata in the PubSub can do the same job. And if you are a client, then you anyways have the access to the full information model. Okay, so that's how you go about accessing the information model.
So now you'd find that in most industrial IoT systems, you have to bring in third-party systems that are not necessarily OPC UA enabled. Yeah. So how do these third-party systems consume information in an OPC UA PubSub network?
Yeah, that's a very good question, and and that is actually a key. See, what happened is when OPC UA PubSub was getting defined, right? They defined two kind of protocols for now. There'll be in future, there could be more, but for now, they have two types. One is OPC UADP, and one is OPC UA going on MQTT and AMQP, right? Which is JSON protocol. Okay. Now, when the OPC is going on, OPC UA PubSub is going over MQTT, AMQP in JSON packets, what essentially it means? Okay, it just means that now, so before that, you know how MQTT works without PubSub, right? In MQTT messaging protocol, you simply have JSON packets going on the broker, which are nothing but key value pairs, right? So without OPC, in typical MQTT, you have client or the third party, the people who are using that protocol defining those packets. I'll define, an object and I'll tell you what object it is, and you can use that object as it is, right? But when PubSub came in and they started using the same protocol, okay, they defined those packets, they standardized those packets on their specification. Okay, but because they have standardized, but they are still same JSON packets. So now any MQTT client, okay, which is there in the market, which is already capable of intercepting MQTT packets, can actually take OPC UA PubSub data because they are just JSON packets. Plus, they're anyways getting the data set metadata to intercept that data in a better way. Okay, so you do not be a OPC UA client. Okay, for example, you have this MQTT FS client, right? But there are so many MQTT clients, okay, which are actually able to see these packets. Okay, in fact, as I said, our product that we'll discuss later on, we whenever we do a demo, actually we use these are clients to show that flexibility that just need to have MQTT client and not OPC UA client. And most of the cloud players are also doing that. Right. In their data ingestion layer, they have built-in MQTT support, okay, because of which they can just get the data from OPC UA PubSub. Okay, so that's how any third party can get the data on the MQTT part of it.
Okay. So another technology that always comes up when we talk about OPC UA PubSub is TSN, time-sensitive networking. Can you describe what that relationship is like and where is it best applicable?
Yeah. I think, so this is where we are moving towards now, right? See, what happened is, as I said, the more better you are, the more use cases you get. And the more use cases you get, you become better, right? So because of the classics hit, OPC UA was born and, everybody started using it. And then when OPC UA became such a big hit, many more industries started coming in. Then now we have industries like security or the robotics coming in, trying to use OPC UA PubSub. And you also have the field level communication, where deterministic data is very important. When you are doing a field communication, you are moving data at the field level, data has to reach at the time it has been given. If a delay is said to be a 5 millisecond, it has to be 5 millisecond. It cannot be 5.5 millisecond. And that is called deterministic communication. Now, by nature, our Ethernet that we are using, on our laptops or on our network is not a deterministic communication. Okay, the TCP/IP stack or underlying Ethernet is never a deterministic communication. They will simply say, we suggest you, will tell you that we will try our best to give you data at 5 millisecond, but it may become a 6 millisecond as well, which is not acceptable in these industries like robotics or safety or in this field communication, because there that is the key property. Okay, just to give a simple, I mean, it may not be a real example, but just imagine you are moving a robot 2 arms, right? And just both the arms are getting controlled by OPC UA communication. Okay, and you are moving a glass from this hand to this hand. If this signal comes at 5 milliseconds, this comes at 5.5, this guy has released the glass, but this has not holding the glass, right?
Yeah.
Where's the glass now? On the floor, right? So that is deterministic communication, right? When this guy is leaving the glass, this guy has to hold the glass, right? They have to exactly behave or react at the same time. That's called deterministic communication. Just a very simple example. Now just imagine that happening at the field level. Okay, that's why OPC UA, when they started as they call OPC UA TSN, now it is called OPC UA FX, which is field exchange communication. It is driven by FLC group, field level communication group. So to move the data at the field level, which is controller to controller, controller to device, okay, they are going for the TSN, but that's not the only application. I think robotics will use it. Safety industries will start using it in future.
Ah, okay, interesting. Now, the fact that OPC UA Client-Server can be used in conjunction with OPC UA PubSub. Can you describe to us like some use cases where that kind of scenario would work?
Yeah. So as I said, most of the devices, right? Most of the devices which are running at L1 layer or L2 layer, L0 to L2 layer, I'm talking about. See, they have to move a data in multiple ways. Okay. Now the need is that the industry is saying the real-time communication which was happening in the plant in the OT layer, below OT layer, right? In the real-time communication, that is still there. That communication is still happening, but they want now cloud connectivity as well. They're saying, I want the same data to come to a cloud for my own work. Okay. Now, because these are two different requirements, they have to be addressed by two different protocols. Okay. One is for the OT communication, where it is real time going to the next layer, but has to be much faster and small chunk of data is getting moved. You use OPC UA TCP/IP. Okay, which is running in OT layer, has a lot of security built in. Okay, and when you want to move a same kind of data, but you are moving to a cloud, but their time response is not very critical. Okay, if the data goes after 2 seconds, is no big deal because they are using for future analytics and for finding patterns and other thing, doing predictions. Okay, but when you have to take immediate decisions on that data, okay, like setting a set point or removing reducing a temperature or increasing a pressure based on that data, the time response is very critical, right? So in the field, in that OT layer, okay, TCP/IP is still used and will be used, okay, because it's faster. Whereas when you are moving a data to a cloud, you have to go to the MQTT or MQP kind of protocols. Now, if the same device or the same software is doing both the work, it has to have both the endpoints, right? To move the next layer, the real time, you have to use a TCP/IP. And to move data to a cloud, you have to use any PubSub mechanism or broker, basically.
I think it was late last year or early this year when the OPC Foundation announced the commitment by some cloud companies such as Azure and AWS to support OPC UA PubSub, right?
Yeah.
Can you describe to us how OPC UA PubSub integrates with Azure, for example?
So see, so I just explained this architecture, right? The whole architecture of OT, right? What happened is now what has happened is Azure has come up with something called as OPC IoT Hub. Okay, and see what happened is Microsoft came late into the but they have now massively invested, and they are the main contributor to the foundation. Okay, and the .NET Standard Core stack, which is in the GitHub, right, is being contributed by Microsoft, and they are maintaining it, and they themselves are using it big time. Okay, because they realize that OPC UA PubSub is going to be a de facto protocol in future by all the industry. They started building their entire IoT hub on OPC UA PubSub. Okay, so actually, if you look at the Azure IoT, they have these components. They have OPC UA Publisher, okay, which does the same job. It can connect to a native below protocols. It can connect to the below devices and get the data and convert to OPC UA PubSub. Okay, so now current publisher just connects to a OPC UA TCP IP as a client, okay, from below server and converts to PubSub, but there could be other publisher who can do the job. Okay, and I'll talk about that when I talk about the PubSub Bridge actually. So they have the publisher where they take a data from OT layer, which is coming in TCP IP that we discussed in the last section, and convert to PubSub. Once it is PubSub, it can come on the data ingestion point where the IoT hub starts. And when it has come there, all the components that IoT hub has it, where they are processing the data, doing work on the data, they natively understand OPC UA PubSub. And Microsoft has many a time discussed that and talked about it. Okay, so they have built their entire IoT hub based on OPC UA PubSub. And actually, because of that, we are getting that push. So when I said, sometime back, the industry started demanding PubSub and all that, right? Because cloud players were actually pulling from their side. Because they finalize on this protocol that they will be using this protocol for moving a data and making all our components understand this protocol natively. Okay, there's a huge demand of the PubSub to get come down at the OT layer. So that's how you take a data from OT layer, you move to a cloud at a data ingestion layer, and then all the components understand the data.
So maybe let's dive into the uOPC PubSub Bridge, right? Which is a product of Utthunga, a company that you are a part of. Can you give us an overview of uOPC PubSub Bridge?
Before that, I see we have discussed all the aspects, but we have not talked about security. Can we touch on security a bit?
Yeah, absolutely.
Absolutely. Yeah, because security is something which is very interesting in a PubSub world, Yeah. And I wanted to actually discuss that also before I go there. So, see, again, in PubSub, security again has come from the OPC UA TCP IP world. Okay, so let me first explain how it works in TCP IP, and then I'll use the same context in the PubSub. Okay, so in TCP IP, when you're building a channel, okay, when you're doing a two endpoint connection, okay, you have a SSL channel or TLS channel built there, okay, using the public-private key, okay, and it is an asymmetric key encryption. Okay, so it's a very strong encryption, but it is slower because typically data movement transfer is always inversely proportionate to the encryption technology, So what OPC UA did is, what they did is they did smart work there. Is when they are building that channel, they use this asymmetric encryption, okay. But once the channel is built, which is encrypted, the first thing they do is they actually build a session key on top of that. Okay, they generate a session key for the message encryption, okay, which is symmetric keys. And symmetric keys run much faster than asymmetric keys. In asymmetric key, data transfer happens in kilobytes, whereas symmetric could be in megabytes. Okay, so they have a session key to do rest of the encryption. Now, when a PubSub was getting designed, okay, now you do not know the publisher and subscriber, right? Because they are decoupled architecture. How do you go about it? Okay, so they extended the same concept here. Okay, and they bought a third component. So first thing is you have same kind of symmetric keys, which are session keys available in the PubSub. Okay, and for that they have bought in the third component, which is called secure key service. Now, secure key service could be an independent component or could be a part of server or client or publisher subscriber. But when they are connecting to it, they have to use the same secure encryption mechanism that I talked about. I mean, that's how the functions are given. So they are UA server and client, that which I've been emphasizing earlier, right? You get this default. So if you have the secure connection, on top of that, you can get the secure keys from the secure key server. And for that, you have a security group where, you have to register and get the keys. And once you have that keys, you can do the encryption. Okay, now, why it is important? See, in case of broker, when you have a broker, okay, you have a broker security coming in picture, right? When you have this AMQP and MQTT broker, they have their own security, which is independent of the security I talked about. So you can have that security and this security running on top of it. But when you have UDP communication, in the UDP communication, you don't have the security at all because there's no broker, right? It is just a network layer, right? And there, this security becomes very important. And that's how you use PubSub secure keys to encrypt the messages. And that is important part of the PubSub. Without that, I don't think people will use it in the field anywhere. The security has to come.
Yeah, that makes a lot of sense. Yeah, thanks for that addition. Yeah, so if you could then maybe give us an overview of the uOPC PubSub Bridge. So as I mentioned, this is a part of your product line at Utthunga, right?
Yeah.
And so yeah, if you could give us an overview of the PubSub Bridge.
Sure. Can I just share my screen for that?
Yeah, absolutely. Let me see.
So let me, I'll just run through a couple of slides where I'll talk of a couple of things, okay? And
yep.
So let me start with the what our company does it, okay? And then from there onwards, I'll go towards our product. So Utthunga as a company, it's a product engineering solutions company. Okay, we do product engineering services for OEMs, ISVs, so that product that we talked about in last session, right? You have the PLC drivers and RTOs and all that, right? We have actually built the OPC UA server on many of them for the end-party customers or third-party customers. Okay, so that is one part of our story. We also help people build solution for them in their plants. So suppose there is a plant where you have a lot of brownfield components, the old components, I mean to say, and you want to move towards, we can help them. Okay, we were established in 2007. We are around 15 years old. Okay, and now we are 800 plus. We are primarily headquartered. I mean, we are headquartered in Bangalore. We are primarily in India. Okay, and we have offices, in Europe, in USA, in Japan. But these are mostly sales office, business offices. We plan to expand there, but our workforce is basically in Bangalore. Okay, and we have been part of foundation. In fact, the product that we are going to talk about was actually started getting built, or it was built to test the PubSub protocol when it was just getting built by the foundation. We were one of the members who were writing early samples for PubSub, and that's how the product got built. Okay, and so let me just go to the next screen. Yeah, so as I said, we are the corporate member till 2008. Okay, we have been contributing to the OPC big time. In fact, for the first time, when the OPC day happened in India, okay, when OPC Foundation member came to India, we were the guys behind that. We got them to India. We had a conference and all that. Okay, and we are the core. I mean, three of the people, me, Smita, and Chhatrapati. Smita is also a co-founder of the company. Okay, we are the listed OPC experts on the site. Okay, and that's how we are that heavily we are involved. Basically we are a technology forward company, and that's why we participate in most of these technology consortium bodies. Because there you come to know what is going to come tomorrow. They are defining tomorrow's technology, and we start building product on that. So when the market reaches there, we are ready. Okay, and that's giving us a lot of advantages till now. Okay, and these are some of the groups that we are part of it. Some of the strategic partners that we have it. Okay. Now, to coming to my product that we are discussing. Okay, so this is a product that I was talking about. Okay, see, before I actually go there, now that OPC UA PubSub has been established very well. Okay, and people understand what PubSub is. Let me bring another use case that PubSub does it. Okay, which was still not there, which was DMZ gateway. Okay, what is a DMZ gateway? So let's first understand what is DMZ. In the automation world, DMZ is a key concept where what happens is IT network and OT networks are separated. Okay. See, OT network is holding all the key components, all the key infrastructure, right? So if an attacker reaches there, if a hacker reaches there, it can create a catastrophe, right? And IT network has to have internet because all the office guys are working there. Okay. And IT has to connect to OT, but with a lot of security. And that's where DMZ comes in, where they create this gap. They create this zone where IT guys have a limited access to the OT via firewalls. Okay, and now there's a need to move data from OT to the IT with the help of these firewalls. Now, in case of OPC UA TCP/IP, because client used to start the communication, as the client is an IT layer and the server in OT layer, the firewall port has to be open downwards, inwards, which is not a good thing because the same port can be used by other people. But if you look at PubSub, publisher publishes information, goes to broker, broker gives some data to the subscriber. So data always goes one way. The data direction is always one way. Now just imagine if the data, if you are using the same data in the plant, okay, the firewall port has to be open upwards, outbound ports, right? So all the publishers are sitting in OT environment, publishing a data, and the brokers in DMZ layer, okay, and from there subscribers are picking up, all the firewall ports are open upwards. That means there's no security compromise. Okay, so we are pushing the envelope, and we have published article on this also in the foundation newsletter that PubSub can be the new technology, okay, to act as a DMZ gateway. Okay, now coming back to my product. Okay, see, so in OPC or PubSub, you have a publisher, you also have a subscriber, right? But this product can act as a publisher as well as subscriber. Okay. In the same product, in one installation, you can have some component acting as a publisher and some component acting as subscriber. Okay. Now, because of that, we are saying that this product can be an ideal product to act as a DMZ gateway. Just imagine one instance of product running below in the OT layer. Okay, getting a data from the OT. Currently, my product supports, as you can see, UA server, DA server, database. We also have Modbus coming up. Okay, which is not released yet, but it is there. Okay, so I was talking about these OT technologies, right? The old technologies, the field protocols, right? So DA server is like a OPC classic server. UA that you are aware of it. Modbus is a field protocol. My publisher component of my product can talk to all these lower level devices, get the data using that protocols, convert to OPC UA PubSub, and put it on the broker. And I can have another instance of my same product running in the IT layer, okay, acting as a subscriber and picking the same data and putting in the IT layer. Okay, so two instances of the PubSub working across IT OT layer can act as an ideal DMZ gateway. Okay, that's one use case. Second is that we talked about the data to cloud, right? We already have this product in marketplace. A PubSub Bridge has already been published on Azure Marketplace. Okay. And we are also going to soon have this as an OPC publisher module. I remember at some time in the last session we talked about Azure IoT Hub has a publisher module where it gets the data from the South protocols, South side protocols or the OT layer protocols and converts to OPC PubSub. This is a classic example. I'm getting data from all the field protocols, converting the PubSub and pushing it to cloud, right?
Okay. Sorry to interrupt you. So as a module there, is it because I know that with the with the publisher module from Microsoft, you can deploy it onto Azure IoT Edge runtime. Is that going to be the case also with
yes?
This?
So in a month, 1 month or 2 month time, we'll be there. So we already are in the marketplace, but currently it comes to us. We are going to natively be an Edge module there. So you'll have that Edge container, the Docker image that typically you have it. You download in the Azure and you connect to this outside in the OT layer and get the data to the cloud. We are working on it.
Awesome.
Okay, so that is, and another thing, is that the protocol bridge. See, what happened is when you have this UDP communication or field communication happening, it is limited to a local network. Okay, and in the plant you have a different subnets. For security purpose, they segregate the networks. Okay, so that when a hack happens or some security compromise happens, not everything should get compromised. At the same time, they want to move a data. Okay, now suppose there are two subnets which are segregated completely, but some key data has to move. Okay, again, you can use PubSub. You can have on subnet 1 having a publisher pushing a data to a DMZ layer broker in a secure TLS with a OPC UA security built in. And in subnet 3, another instance of that, picking up that data and mapping back to the different points. And that way now you are actually moving a data from subnet 1 to 3, which was not possible till that time. So with PubSub, we realized that the technology allows it. Right? The technology was built to allow this kind of use cases. And because my product can act as publisher as well as subscriber, same product with the two instances can do that job. Okay, so the functionality remains the same. It is doing the same job in each case, but you can use as a DMZ gateway. You can use it to move data to a cloud. Okay, or you can have a protocol bridge. The biggest advantage is so some of the key advantage here is in case the PubSub bridge loses connection to the broker. You know that broker that we're talking about.
Yeah.
Okay, it has a store and forward option also. So what happens is you can enable this option where the moment I use connection to the broker, I'll start storing a data into a DB. Okay, and the moment I recover my connection, I can start pushing back the data on the broker. So you lose no data. And there are different modes, how you push a data. I can push both historical data, live data on the broker. I can put in a sequence based on the client requirement. So because of that, we are saying that, it can give you a free loss-free transmission or noisy link. If the connection goes, no problem. I have stored all the data and giving it to you. Okay, so that's where PubSub Bridge has become a key product. We have number of clients. We already have clients which is using their frameworks. Okay, we have other clients who are already interested, and soon it will be part of the Azure IoT framework. Okay.
Okay.
So yeah, so that is about PubSub.
Okay, so that brings us to the end of this podcast. Praveen, it's been an absolute pleasure to have you on the show. Thank you so much for coming through.
Thanks again, Kudzai, for inviting me and having such an intense discussion, having such a good questions. It just helped me explain information in much better way. Thank you very much for calling me.
Thank you.